Okay, this is the problem that was posted right here, where you're supposed to find x and y given that you had a big right triangle ABC with an altitude drawn from the right angle perpendicular to the hypotenuse. And we're using these two corollaries. It turns out that there's 3 pairs of similar triangles created when you do this, and we'll talk about how you identify them after we look at this problem. This is the corollary we're using. A leg of the big triangle is the mean proportional, or the geometric mean, between the entire hypotenuse and its projection onto the hypotenuse, or the segment of the hypotenuse that it's adjacent to. So it's easiest to solve for x by looking at this leg. It's the mean proportional, or the geometric mean, between the entire hypotenuse, which is x, and this is x minus 9, because the whole thing is x. This segment is 9, so this is x minus 9. So if you solve this equation, cross multiplying, getting a quadratic equation, factoring, we'll cancel or we'll reject the -3 since we're dealing with segment length. So x is 12. And if we put this 12 here, we can put a 3 on this leg of the little right triangle. And then you have two choices how to find y. You can use the Pythagorean theorem. Sum of the squares of the legs equals the square of the hypotenuse. Or you can use the geometric mean corollary. Y is the mean proportional between the entire hypotenuse and its projection onto the hypotenuse, which is 9. So you get the same answer either way. And I'll just mention over here, if you ever have a diagram where you have this situation and you need to figure out what the similar triangles are, I suggest filling in 30 and 60 for the acute angles of the big triangle. And that allows you to fill in these little angles here of the little right triangles. And then, like, if you have to figure out the similarity relationship for the big triangle with, let's say, triangle number 1, and the big triangle, angle A is the right angle. So in triangle 1, D is the right angle. So I know to put a D there. And in the big triangle, B is the 30-degree angle. So in the little triangle, B is also the 30-degree angle. And then similar for 60 degrees. Okay, and you can follow the same pattern for big triangle versus triangle 2, or 1 similar to 2. Just look at the 30s and the 60s and the 90s to see what angle corresponds to what angle. Okay, there you go. Hope that helped. If you have any questions, post a comment.